Alright, try number 2. So, I'm going to go as fast as I can to conserve time, so I won't be talking a lot. I already did this problem once, and I made a slight error, which I only caught about 15 minutes into it. So I had to return and do it again. Alright, so here's a practice radical that I did, similar to yours. I made a mistake. So here we go again. Those are my critical points. Let's test them. Okay, those are my critical points right there. I don't know if that got out of the viewing area. Top equal to 0, bottom equal to 0. Very important. Let's test them. Drawing something so I can have an idea and don't have to plug everything into my calculator. This yields does not exist because it's not part of the domain. We'll go over that later. So does this. Yields the same thing, does not exist. CP, CP, CP. Now this will yield negative times a negative is a negative. Negative, well, that's always positive. Wait, I'm sorry, that's shameful. Negative times a negative is a positive. Write your interval. Alright, here we go. We got everything we need. Moving on to step B. Keep in mind it does not exist after negative 3, or before negative 3 and after 3. We'll go over that later. Here's where it gets ugly. Do the derivative. Chain rule. Points of interest becomes 1/2 times 2. This right here is bad. You can't set the top equal to 0 with a negative exponent. Okay? Can't set the top equal to 0 with a negative exponent. Moving on. So we go to get rid of it. Okay? Get rid of the bad thing. How do we do that? We can't just flip it to the bottom. That would be bad. We have to bust it up. Okay? 1. This 1/2 becomes this. Combine. One. I split it up. Now we can flip it because it's a factor. Now that it's a factor, we can flip it. And that's in parentheses, I apologize. 1 times 12x squared, 12x squared. And my light turned back on. Now this has become here. Simplify. Now, got to combine. Need 1 fraction in order to do this. Okay. Combining fractions requires common denominators. What's this missing that this has? Right here. Now, 1 second. Notice these 2 exponents right here. When I multiply, I add the exponents. So it becomes 1. Never multiply the bottom. Now something wonderful is about to happen. It's about to get a lot easier, fellas. Okay? So, distribute. Continue simplifying until it looks really good. sure you can already see what's happening. Now we can combine. So now it looks really good. Let me zoom in a little bit. Now, cancel. That exponent is 1. Add. Beautiful. It comes out to be very simple. Okay? Now, we're going to find our points of our inflection points. Okay? Our inflection points right here. So let's go ahead and do so. Set the top equal to 0. And we can go ahead and set the bottom equal to 0 too. Okay? I'm going to raise both sides to the 2/3. Okay. Cancel. Becomes 1. Potential inflection points, but they may not be, as you'll see in a minute. Okay. No solutions. Okay. Let's test. Write it out. All right. Now, top equal. When I plug in -4, I get the same thing. This is basically square root of 9 minus x squared to the 3rd power. When I plug in -4 here, I get 9 minus 16. It's a negative. Does not exist. I plug in 0 into x. This is always going to be positive because of the square root. When you're evaluating square roots, they're always positive. When you're solving for square roots, you get a positive and a negative. Okay? So this is a different situation. Positive and negative here. When I'm plugging it in, I'm expecting a positive answer. This is always going to be positive. So when I plug in 0, I end up with a positive on bottom and then negative on top. So negative. Concave down. Okay? When I plug in 4, I'm going to get the same thing. So it does not exist. Alright, that's the first and second derivative test. Alright, next, the next step, I want to give the points of extrema. Okay, so go back. Critical points 3, x equals 3, negative 3, 0. F of 3, plug it in. What was it, 6? It was 6 on top, right? Six times the square root of 9 minus 3 squared. Okay. F of 3 is going to equal 0. Likewise, f of negative 3 will also equal 0. And f of 0 remember, evaluating, always positive. Positive 3. There we go. I got my critical points. Evaluate them. These are endpoints, as you'll see in a minute. And this is a relative max due to our sign chart. If you remember, it was right, relative max, so because it's increasing to decreasing on our sign chart, and an absolute max. Alright, D. X and Y intercepts. Oh, I need a new pencil. I already wore that one out. Set y equal to 0. So now 0 equals 6 square root of 9 minus x squared. divide, square both sides, square root both sides. There we go. Y-intercepts. Plug in 0 for x. We've already done that up here. There's my y-intercept. Okay. Moving on. Horizontal asymptote or slant asymptote or vertical asymptote, there are none. Okay, because we cannot have a number over 0. There's no way that you can get a number over 0 here for a vertical asymptote. We're not doing slant asymptotes at all, and the limit as x approaches infinity does not exist. When you plug infinity in, you end up with a really big negative number. You can't take the square root of a negative number. So there's none of this, and this is can't do. Okay? Alright. So F, that was the vertical asymptotes. None. G, the domain. Very well. Take the original function. The domain restriction here is that 9 minus x squared has to be greater than or equal to 0. So, solve. Alright, divide, and it flips. Now, when I take the square root, I keep the sign the same for the positive answer, and I flip the sign for the negative answer. Whoops. Simple as that. My domain, it's right here. Okay, so guys, it's a lot of work so far, but we're not quite done. In fact, we've done all the hard work. We're completely done with all the hard work. So let's move to the easier part. We're just going to make our sign chart, noting the domain. Our interval is only -3 to 3. Alright, and then we're going to label our sign chart as we should. Okay? And I'll make printouts of all this stuff. Okay? Now, G is as such. So, B, C, D, E, F, G, H. Now we don't have negative infinity to infinity right here. Let me pan out. We know our domain is negative 3 to 3. So, it is a critical point, but it's an endpoint as well. Zero is a critical point. The inflection points were here and here, but since they're endpoints, you cannot really label them inflection points. Inflection points cannot be endpoints. So if you refer back to the earlier sign chart of the second derivative, it was concave down everywhere. Okay? And it was increasing here, decreasing here. Okay? From negative 3 to 0, 0 to 3. Okay? Alright. Let's make our graph. Alright. So we know our domains from negative 3 to 3. If you refer back to the extrema and the x-intercepts were here, and the y-intercept was at 18. Okay? We were increasing concave down, then decreasing also concave down. And it's simply a semicircle. So I've got my relative max, I've got my x-intercepts, I've got my y-intercepts. I'm concave down and increasing, concave down and decreasing, and that's all, folks. Okay, so this was quite a long video, so I will give you a printout of an example of the rational function, the tougher rational function that we did. Okay, and the review rational function, I will give you a printout just like I will give you a printout of what you see right here today. Alright, so I'll talk to you all in a little bit. Thanks. Bye.